This is Sakshi and I welcome you all to my EduTech platform, Way to Learn. So today I'm going to solve some of the problems for Csir-Net physics exam and GATE physics exam. So today's topic is from classical mechanics. So the topic from classical mechanics is stability analysis. So before I start, let me start with a quote which will boost your confidence. So with confidence, you have won before you have started. So do not lose hope and keep practicing. So let us analyze the last 5 years question paper and get to know what are the marks that we can gain from classical mechanics. So 3.5 marks, there are 4 questions allotted to 3.5 marks and 3 questions allotted to 5 marks. So these are approximate number of questions. So one can gain around 29 marks from classical mechanics. So this is a huge mark so that one can increase his or her cutoff. So let us start. Under stability analysis, we are going to find the equilibrium positions, stable equilibrium points, unstable equilibrium points, and angular frequency. All these are going to be done using the potential given, E of x. So I have drawn a graph between V of x and x, V of x versus x. So I'm going to say what are these 2 points. So this point is over here is stable equilibrium point, because if I move this object towards its right or towards its left, it is going to come down to its original position. So this is stable equilibrium point and this is unstable equilibrium point, because when it goes to its right or towards its left, this is not going to come back to its original position. So this is unstable equilibrium point. So let us see what are the steps to solve the problems from this topic. So always there will be a potential given in the question. So if there is no potential given, one can find the potential using the force given in the question. So this is the relation that we know. And what is the condition for equilibrium? So one has to find the equilibrium points. So one has to take the first derivative of the potential and equate it to 0. That will give you the equilibrium points. And to find whether the equilibrium points are stable or unstable, so one has to take the second derivative of the potential given and has to find if it is greater than 0 or lesser than 0. So if the second derivative of the potential is greater than 0, it is stable equilibrium point, and if it is lesser than 0, then it is unstable equilibrium point. And using this, the next step is to find the frequency of oscillation. We know that omega is equal to root over k by m. So here k is the force constant and m is the mass. So k and the potential are related by this equation. K is equal to second derivative of the potential. So one can easily find the frequency of oscillation using this relation. So let us solve a question so that we can learn the concept very well. So here is an example. A particle of mass m is moving under a one-dimensional potential. We have a potential over here. So here a and b are positive constants. Find the equilibrium points. So we have to find the equilibrium points and find the frequency of oscillation about the stable equilibrium. So let us find the solution first. The first step is to find the equilibrium points. We have to take the first derivative and equate it to 0. So on taking the first derivative, one gets this equation and one can find the x value, which is the equilibrium point. So I hope you get this first step. So now the second step is to find if the equilibrium point is stable or unstable equilibrium point. So how do you find if it's stable or unstable? We are going to take the second derivative of the potential. So once you take the second derivative of the potential and substitute the equilibrium point, you will get the answer if it's stable or unstable. Over here, I have got a positive value, 2b. So 2b is greater than 0 because b is a positive constant and 2b will be greater than 0. So The second derivative is greater than 0, hence the point is stable equilibrium point. Now the third step is to find the frequency of oscillation at the stable equilibrium point. So we know the relation of frequency and the potential. So we can directly substitute for k value and get frequency omega is equal to root over 2v by n. So I hope you get these steps, follow these steps and learn how to solve such kind of problems. So if you have learned this concept, then this is your homework. You have to solve this problem and comment me the option. I will let you know if your option is right or wrong. So keep watching my videos and you're going to gain so much problems from this video and from other videos so that those will be helpful in your competitive exams. So thank you. Please do not forget to like my video, share my video, subscribe my channel and do not forget to hit the bell. Only when you hit the bell, you're going to get the notified from my videos. So thank you. Bye bye.